What's up geeks, and welcome to the channel. Starting this video and the next couple ones, we're going to look at the Docker client or Docker CLI a little bit more and learn about the very basic commands that we use to interact with Docker containers and images. So let's get to it. The first command on the list is one that we ran very briefly before, and what it does is create and start a container using an image. This command is docker run followed by the name of the image that we want to use as the basis for this container. Now, we've already gone through this process in detail once before, but you see there's a lot of variations in this docker run command and a lot of very small subtleties around it. Okay, the variation we're going to start with is going to give us a way to override the default startup command of an image. Remember, anytime that we execute docker run with an image, we not only get that file system snapshot, but we also get this default command that is supposed to be executed after the container is created. So, to apply this variation, we'll execute docker run, followed by the image name just like we did before, and to do that we're going to use an image called busybox, and I'll tell you why in just a moment. Then after that we'll supply an alternate command to be executed inside the container after it starts, and that command will be echo hello from Geekific, so whatever default command is included inside of the image is not going to be executed, this one is. So this right here is the override. This is a command that we executed inside that container. The echo command is going to print out hello from Geekific inside the terminal, and as expected, after we execute this command, we can see that output. Now let's try something else and run docker run busybox, and then the override command that we're going to use this time is going to be ls. If you've never used ls before, it's going to print out all the files and folders inside of a given directory. So let's try running this and see what happens. If you are on a Windows machine, these folders might look very strange to you and very unfamiliar. In fact, these folders do not belong to you. These are folders that exist solely inside that container. Remember that each image has some default file system snapshot and some default startup command. And when we create a new container out of an image, we take its file system snapshot and we stick it in a container. And that is why we can see all these folders. They were created alongside the container because they are defined in the busybox image. Now, one thing you might be curious about is why we chose to use the busybox image here as opposed to the hello world one that we were using before. To answer this, let's bring back the terminal and try to run hello world with the echo or ls command. As you can see, we got an error in both cases. Why? Well, the issue is that ls and echo are two programs that exist inside of the busybox file system image. Somewhere inside the folder system of that image is an actual ls executable and an echo executable that allow us to safely execute those commands. However, with hello world, the only thing that exists inside this file system snapshot is a single program, one single file, and all that thing does is print out the message we saw when we ran that container. So the startup commands that we are executing are based on the file system included with the image, and if we try to execute a command inside the container that uses a program that is not contained within its file system, we're going to see an error. Okay, let's take a break from docker run for the moment and look at one of the most used and most important commands out there, docker ps. This command will list all the different running containers that are currently on your machine. When we run this command, we'll see some headers for a table and no records, as we have no containers currently running on our machine. You see, we've only been running images or creating containers that run very quickly and then immediately close. For example, when we were running docker run busybox echo hello from Geekific, that container starts and then almost immediately exits back to the command line. So if we want the output or PS to be meaningful, we must have some container that is running for some longer amount of time. To do that, let's try running docker run busybox and then let's ping youtube.com. This is a command that's going to continue running for quite a long time. Okay, we can now run docker ps in a second terminal and we should see this container. This is the information for the container that is currently running and issued the ping command. We can see the container ID, which we can use for a lot of other operations that we will investigate at a later stage. We can see the image that was used for the container and its startup command. We can see how long ago it was created and its status. And then at the very end, we'll also see a randomly generated name to identify this container. Okay, let's abort the ping command and try to run docker ps a second time. We won't see that container anymore, so the ps command specifically shows running containers. If you want to see all the containers that have ever been created on your machine, all you must do is add $all or -a at the end of the command. When executed, that command will list all the containers that you created. Okay, to manipulate containers, and besides the run command variation and the ps command, the next command we're going to use is docker exec. Exec is short for execute, and we use it to execute an additional command inside of a container. So, to really grasp the benefits of this command, we're going to run a new container based on the Redis image and retrieve the Redis container ID with the help of docker ps. A small parenthesis for those who don't know. Redis is an in-memory data structure store used as a distributed in-memory key-value database. Once we have it, we're going to write docker exec-it. This little argument allows us to type input directly into the container. We'll then provide the container ID and then the command that we want to execute inside the container. And when we do that, you'll see that we get a familiar looking command prompt where we can write out something like set my value 10 or get my value which returns 10. These are basically Redis commands. We are now playing around inside the Redis container. So by using the exec command, we were able to start up a second running program inside of our container, and the -it flag right here allowed us to provide input to it. Okay, let's try removing the IT flag and see what happens. This time we got kicked directly back to the terminal, and that's because Redis CLI started up but realized that it doesn't have any possibility of getting any text input, so it decided to just entirely close and kick us back to the terminal. Now, to understand what this flag really does, we'll need to understand a little bit more about how processes run inside of a Linux environment. As we previously mentioned, all these processes are really being executed inside of a Linux world, even if we're on Mac or Windows. So, in theory, every process that we create in a Linux environment has 3 communication channels attached to it that we refer to as standard in or std in, standard out or std out, and standard error or std error. These channels are used to communicate information either into the process or out of the process. So when we're at the terminal and type stuff in, the stuff we type is being directed into a running standard in channel, whereas the standard out might be directed to the running terminal, which is going to process stuff that is supposed to be shown on the screen. Okay, that's great, but how does that relate to the IT flag? Well, the IT right here is 2 separate little flags. It's a -i and a -t. But by convention, we usually just kind of shorten it down to be simply IT, which is 100% equivalent to the 2 separate flags. The -i means that when we execute this new command inside the container, we want to attach our terminal to the standard in channel of that new running process. So we are saying that any stuff that we will type will get directed to the standard in of Redis CLI. And the -t flag is what kind of makes all this text show up a little bit pretty. Now, in reality, it's doing a little bit more than that, but at the end of the day, the real effect of the -t flag is to make sure that all of the text coming in and out shows up in a nicely formatted manner on our screen. To see this in action, let's try running docker exec one more time while leaving off the -t flag. This time, you'll notice we can't see that nicely formatted indentation we had before. And if we put in set my value, that autocomplete functionality we had is not there. Finally, a very common thing that we're going to want to do when using Docker is get shell access or terminal access to a running container. In other words, we want to run commands inside the container without having to rerun docker exec again and again. To do that, let's execute docker run -it busybox followed by sh. When you run this command, you'll notice we get the little pound over here. We can now start to type typical commands that you'd expect to be able to run in a Linux environment. So, for example, we could change our directory. We can list out the files and folders. We could execute commands like echo. We can export environment variables, etc. So essentially, when we made use of this docker exec command alongside sh, we got full terminal access inside the context of the container, which is extremely powerful for debugging. But what is sh? Well, sh is the name of a program. It's a program that is being executed inside that container. sh is a command processor or a shell. It's something that allows us to type commands in and have them be executed inside that container. Note that we are already making use of a program very similar to sh on our computer, and chances are if you're on Windows, you're probably using something like bash or PowerShell. These are all programs that allow you to type commands into your terminal and have them be executed. Usually a lot of the different containers we'll be working with are probably going to have sh command or program already included with them, so in most cases we can make use of bash directly. Okay, up until now we ran containers and manipulated them, and that was interesting because it kind of begs the question, when does a container really get shut down? Why does it get shut down? How does it get shut down? And what happens when it gets shut down? Well, stay tuned because all these questions and more will be answered in the next video of this series. So that's it for this video. I hope it was helpful. Thank you guys for watching, take care, and I will see you in the next one.